Hi folks, welcome back. I hope you're all doing well. One of the holy grails of large language models continues to be reasoning on complex problems. And the way people have typically approached that problem is by proposing various prompting mechanisms. We have, of course, zero shot, which is the simplest one, but then we have few shot prompts with a few examples. We have chain of thought, which is really popular and pretty effective, but a whole bunch of others, many of which I've covered on this channel. The problem though is they're each best suited to a specific type of problem. And before you even try to solve a problem, you have to first think about what kind of prompting strategy to apply to solve it. And that is the problem that this paper tries to solve. It adds one more layer of indirection on top of all these prompting strategies by first asking the LLM to introspect and choose the most suitable prompting strategy for a given problem class, and then use that. They call this approach self-discover, and at a very high level, the way it works is that you start with your base language model and a large collection of what they call reasoning modules. Now, these reasoning modules are basically just very specific prompts, like chain of thought could be a reasoning module. Other kinds of prompting patterns could be other reasoning modules. And the very first step is to use this self-discovery pattern to find the best reasoning modules to solve the given task at hand. And then once you've found that, you can apply that to multiple instances of that class of problem. Now, zooming in one more level of detail, the way self-discovery works is in 3 discrete steps. In the very first step, you select from your menu of prompting patterns or your seed modules to pick the ones that work best for the given problem at hand. You then adapt it more specifically to the problem, and finally you come out with a reasoning structure prompt that's the implementation phase. Here are those meta prompts in a bit more detail. You can see how in the select phase, we ask it to pick given the reasoning module descriptions. Then we adapt it by asking it, the LLM, to rephrase each module to better solve the problem. And finally, the implementation phase comes up with a more specific problem that can then be used to right away solve specific instances of this class of problem. To start with, they have 39 reasoning modules, and they were taken from the Prompt Breeder paper. I've covered that paper on this channel before. I'll leave a link in the description. But you can see how all these different prompting styles or prompting strategies form a menu of different types of reasoning. Things like critical thinking, or use systems thinking, use risk analysis, use reflective thinking. So these are different problem-solving approaches. So what do the results look like? On benchmarks like BBH, Big Bench Hard, or math, or agent reasoning problems, they compared it against direct prompting, so just giving the problem itself as a prompt, and chain of thought prompting. And against both of those strategies, self-discovery comes out ahead by a very decent margin, as you can see in this graph. Each bar here is one task of that benchmark, and self-discover outperforms direct answering on 23 out of 25 tasks and outperforms chain of thought on 21 out of 21 tasks. All right, so that was a very quick look at the self-discover paper that introduces kind of a meta prompting strategy that lets you choose the best prompting strategy for a given problem. There's a lot more interesting detail in the paper. Take a look. I hope you enjoyed that. If you like content like this, please like the video, consider subscribing, and I will see you next time. Thank you very much.